So hello everyone, I hope you all are fine. So today we have the questions on what we have been discussed in the previous lectures about the Markovnikov and anti-Markovnikov rule. So we have the question number one. Without wasting any time, let's get to the question number one right now here. The HCl with an alkene X, some alkene is that's X, reacts in accordance with the Markovnikov rule to give 1-chloro 1-methyl cyclohexane. Okay, this is the product. 1-chloro 1-methyl cyclohexane is the product. The structure of alkene is, so I have to see the possibilities which can provide us or which can give us what product. 1-chloro 1 methyl cyclohexane. So this is the cyclohexane, this is 1-chloro and this is 1 methyl. So which alkene among them, there are four options, which alkene among them can produce this product. So if we look at the first one, the first one here is the this CH2 is right now here. So if I add HCl in this, what will happen? The positive part will go to that carbon which has less substitution, so it will get to CH2, and the negative part, according to the Markovnikov's rule, will get to this carbon. The double bond would be breaker to single bond. So what would be the product? The hydrogen will get to the CH2 and it will form CH3, and the chlorine will get attached to this carbon, so it would be 1-chloro 1-methyl cyclohexane. So this can form the, I mean, 1-chloro 1-methyl cyclohexane can be formed by this. Okay, so another option we have like this. I write it down like this, that we have another option that is like this, CH3. So what will happen if this double bond breaks in presence of HCl? So H positive will get to that carbon which has more hydrogen atoms, and chlorine negative will get to that carbon which has less number of hydrogen atoms. So the hydrogen will get to this carbon and the chlorine will get to this carbon. So what will be the product for this reaction? The product will be like this. The chlorine will get attached to, okay, the CH3 will get will be like this, and chlorine will get attached to what? This carbon. This would be, the chlorine would be attached to this carbon. So this will be also I mean, this could be also what, 1 methyl, well, 1 chloros methyl cyclohexane. So this can also produce this product. So option number 3 can be correct option, but we have to check about the option number 4. That is always, that would not be, that could be correct. We'll check it down also. So this is CH3 right now. The option number 4 is like this. So if I add HCl in this, H positive will get okay, there we have same substitution right now. So H positive can get to this carbon, or HCl negative can get to this carbon. By either ways, the product 1-chloro 1-methyl cyclohexane will not form in this type. So what will be the answer of this reaction? Will be option number 3. Okay, so option number 3 would be the answer of this reaction. So we have the question number 2 right now here. So if you look at this question, okay, the reaction of C6H5 CH double bond CH and then CH3 with HBr products. So what is the reagent right now? What is the substrate? C6H5 CH double bond CH, and it's attached with CH3 in presence of HBr. So HBr would get attached to added to this double bond, but it would be according to Markovnikov's rule, MKW. Markovnikov's rule. It would not be according to the anti-Markovnikov's, because there is no hydrogen peroxide or any other peroxide present in this reaction. So it will be according to the Markovnikov's addition. So what would be the product? What could be the, okay, the reaction with HBr produces, or what could be the product of this reaction? As we see, okay, this is the C6H5, like this, looks like this. C6H5, then this is CH double bond CH and then CH3. It's so obvious that the double bond would shift like this. It will never shift like this. Why? Because of the formation of stable carbocation by this method. Okay, if the double bond will break towards the this carbon, the positive charge will come on this carbon, the negative charge will come on this carbon. So H positive will get attached to this carbon. So what will happen next? This would be like this. So this will be benzene ring attached to CH positive and then CH2 and then CH3. So this could be the the HBr can be added to this carbon. The HBr can be added to this carbon. It's so obvious. So in option number 2, this CH would get bromine. Okay, this CH will get bromine. That's correct. This CH, okay, can this CH get bromine by any chance? No, the option could not be correct. Can the terminal CH3 get Br? No, that's not also correct. So the option will, this also is not correct. So the option number 1. But if we look at the option number 4, if we look at the option number 4, you know what will happen to this carbocation? It will undergo rearrangement. So it will undergo, because of the resonance, it will undergo rearrangement, or it will undergo, sorry, it will undergo what? A resonance. Okay, after getting into the resonance, what will happen? Positive charge the positive charge right now here would get attached to the positive charge right now here, this is positive charge. What will happen? This will be in resonance. So this double bond will break like this. The double bond will break like this, and what will be formed? It is CH2 and then CH3. What will happen next? The positive charge will come on the ortho position. Okay, the sorry, positive charge will come on the ortho position, and this will be like this, and CH, this will be like double bond here, and CH2 and then CH3. What will happen next? The it will go under further resonance. The double bond will come like this. The positive charge will be like this here, and in third condition the double bond can shift towards this, and the positive charge could be like this. So there is possibility that the bromine could be attached to this. But if you look at this carbon, CH double bond, it's never being formed by any chance. So it's benzene has double bond with C carbon, but there is no double bond between this CH and this CH. So this can never be the product in this reaction, because of this CH double bond. So in this reaction, the CH double bond is not being formed by any chance. So if you look at this, you can be inclined to the option that this could be correct, but that's not the correct, because of the the product is not this in the following reaction. Okay, we have the question number 3. That's also a good question right now. Okay, what's the question? That is 2,3 dimethyl 2 butene can be prepared by heating which of the following compound with strong acid. So what we have 2,3 dimethyl butene. So this is butene, 2 butene. Okay, in on 2 position we have the double bond, and on second position we have CH3, and on third position we have another CH3. So which of the following could bear this? Which of the following can make this product? If this is the product, which of the following can? These are the four options. When reacting with strong acid, which of the following could make this type of acid? Okay, this type of product. Sorry. So the first option right now here. If you look at this question, the product has how many carbons? It's one carbon, second carbon, third, fourth, fifth, and there are six carbon in the product. But if you look at the option number first, it could be terminated as it is. We don't have to look further, because it has 1, 2, 3, 4, 5, 6 and 7 carbons. So there is the conservation of mass will remain same. The carbons will remain conserved. Okay, in this reaction, so the option number first could be incorrect. Okay, we have in those three options, we'll check out the number of carbons: 1, 2, 3, 4, 5, 6. So we have 6 carbons. Okay, we have 2, 3, 4, 5, 6 carbons in this also. 1, 2, 3, 4, 5, 6. So these three have 6 carbon atoms. So we'll check in those options what would be the correct option. If we get into the option number 2, what is actually the option number 2? Can option number 2 produce this product? We'll check it down. So see, this is CH3, this is carbon, this is attached to 3 CH3s. Okay, 3 methyl group has been attached to this carbon, and this is sorry, this is CH. Okay, this is CH2. What will happen if they double bond? First of all, in presence of strong acid, the double bond will break. Now we have to check whether the double bond will break from this side or from this side. Okay, as we are confirmed, and as we know that carbocation is secondary carbocation is stable. So what would be the product? The double bond will shift towards this carbon, and what will be the H positive will come and get attached to this negative charged carbon. So what will be the product? The carbon is attached to C, uh, three C's, three carbons, or three methyl groups, and this will form the carbocation, and this will be CH2. And after this, what will happen? It will undergo rearrangement. As you know, carbocations undergo rearrangement. So what will happen? That this carbon will get attached to this carbon, and the positive charge will get on this carbon. So what will happen? The carbon carbon, and this would be positive charged, and this would be CH, and this would be CH3, because of the CH3 migration here. They are all CH3s, so the CH3 will migrate. Okay, this would be rearrangement. Okay, then it would be like this. It would be CH3 as the, here we have written CH2, actually this is CH3. Okay, this makes, what is this? Actually, this is carbocation, and then after reacting with strong acid, what happens? There is the loss of hydrogen. So we call it as dehydrogenation. So after the loss of this hydrogen, what will happen? The negative charge will come on this carbon, so there will be carbon carbon double bond here. Okay, what will be the product for this? After this, this will be CH3. It attaches to carbon, it's attached to CH3, and then C C double bond will come in place. So this will be CH3. Okay, this is CH3 right now here. If you give the IUPAC nomenclature for the compound, it will be 1, 2nd, 3rd, and 4th position. The second carbon has methyl, the third carbon has methyl, and this myth is probute. So 2,3 dimethylbutane is the name of this compound. So in this type of option, or in this type of substrate, we can make this desired product. So if you check out, okay, so this could be the option. The second number is the option, as we are getting the product in this case. So if we look at the option number third, what will happen? The double bond will break, and hydrogen will get attached, one more hydrogen will get attached to this carbon, so this will be CH2, and positive charge will come on this carbon. So after then, what will happen? The two methyl groups are attached to this carbon, so it can never be 2,3 dimethyl. It would always be 1,1 dimethyl, because of the both methyl groups are attached to a single carbon, and there is no scope for rearrangement. And after the fourth option, if we go on the fourth option, what will happen? The this double bond will break, and this will be CH3. And what will happen? There will be the positive charge. It can undergo rearrangement, but there is no way, because if it goes under hydride shift, same secondary carbocation would be formed, so there is no need to get further rearranged. So what will happen? That double bond can be like this here. So if you name this compound, it would be never 2,3 dimethyl, as both the methyl groups are attached to the same carbon. So it can never be, the substones can never be on the second or third carbon, so this can never also form the desired product what we have been seen. So the option number second could be right for this product. Okay, we'll get back to you. These were the three questions which are more important for the entrance examination. So we'll get back to you, and we'll discuss some more questions on the Markovnikov's rule and the anti-Markovnikov's rule. Till then, stay with us.